Hello everyone. Couple things out of the way first while they're in my mind. We've done the circuit, we've done the test review, we've done a quiz. If you haven't done the quiz, please do the quiz. It's either in Teams or I sent you a copy in LiveGrades if you haven't done it in Teams yet. Number two, please make quiz corrections. If you did your quiz in Teams, all you have to do is go back into Teams, look at your quiz, and write the old answer, new answer, send it to me in LiveGrades. You can even type the answers out. I've done it that way. It's probably the fastest way to get me your corrections. Everyone who does corrections will get some points. You can actually get all your points back. So you can still get an 18 out of 18. I'm not just doing, oh, you only get half credit back. No, you get all credit. Also, the circuit and test review that we've done already, I'm going to wait and put those up in Google Classroom. If you haven't logged into Google Classroom, please do so. One of the things students that I'm seeing the most trouble is if you're not logged out of all your Google accounts, it will not let you log into Google Classroom because it'll see two different accounts going. And some students, your email and password is not working, and that is one of the reasons why. I know because it happened to me trying to log in myself, and now it's causing problems with my Google Play because it's telling me I have this different email address and I got to figure that out. So for this video, let's see, we're almost 2 minutes in. Yeah, I need to get started with it. What I did was just take the staple out of the packet, and if you haven't already, you can, and work with them separately. The first couple pages were the test review and stuff. So then we have exploring similar figures. So I gave you the notes, and it says page 1 at the bottom here. See how it says page 1? If you go further in the packet, you'll see a page 1 at the bottom that is blank. I don't know if you can see that down here, but that's that. I tried to number all the pages so that page 1 in the notes and homework matched the notes that were at the beginning of the packet. Had I had more time to think about it, I would have said, okay, this is page 1 homework, this is page 1 notes, copy this into page 1 homework, or found a different way to number them. So I know it was confusing for a lot of you. So yeah, I just took my packet apart. So in here somewhere, there we go, I have it in color for you. Now I uploaded this in Teams already, but in order to save time on the video so I don't have this very long video, I'm going to talk about each of these sections that I've done already, and then you can pause the video and copy on your own, and then do the next section and copy. So listen then copy is my way that I would do it if you've not started this part of your packet yet. So one of the things I said on the front was read the top part, read this top part, and it says similar figures. Well, what are they? They're polygons that have the same shape but different size. So I could have a small circle and a big circle. They're similar, but they're different sizes. Corresponding, they have the same position. So if I had a triangle that looked like this, and I had a triangle, I mean, they're not exactly the same size the way I just drew them. I don't have my little tracer thing here. Now I can't leave it alone. But they are in the same position. So if I rotated this one, they wouldn't be corresponding because they're not in the same position. Okay, two polygons are similar if, and this is what we're working with, similar figures, if they have corresponding angles and the length of the corresponding sides are in proportion, which is called a scale factor K. I'm sorry if this is a little blurry. Let me see if I can zoom in a little bit and let this be a little less blurry. Okay. So it says show if the two triangles are congruent or not. So I had to figure out which sides are proportional to what. And this one wasn't so bad because angle A is congruent to angle X. See, this one's 35 degrees and this one's 35 degrees. And then C is congruent to Z. They're both 90-degree angles. So from A to C, I colored in orange. And from X to Z, I colored in orange too. That way I could easily see which sides were proportional. And I did the same thing from C to B. I went from a 90-degree angle to a 55. So up here, a 90-degree angle to a 55, Z to Y. I did that in green. And then that left my hypotenuse for both of these triangles. It's in a blue-purple. I can't really tell. I think I did it in purple pencil. So it has three congruent angles. Notice they're not the same size though, but they are similar. And I can show that by creating a proportion or scale factor. Now the important thing for figuring out what the scale factor is I labeled this triangle 1 and this triangle 2. I could have done this one as 1 and this one 2. It doesn't really matter as long as you're always starting with the same triangle. So I put a number 1 here, so I knew to start with this triangle. So what I did was I compared the hypotenuses first. This one is 40 and this one's 25. So I put the first one in the top, the numerator, and I put 25 in the denominator. And I did that the same thing with the green side. I started with triangle 1, went to triangle 2. So I had 32 over 20. Same thing for the third side, 24 over 15. Now how can I tell if they're similar? Well, what I did was reduce each of the fractions. 40 over 25 reduces to 8 over 5. If I divide both of them by 5, I get 8/5. This one, I divided the top and the bottom number by 4. And 24 over 15, I divided both of them by 3. And notice I get 8/5 for all three of them. Because all three are 8/5, the scale factor is 8 over 5, or K is 8 over 5, so they are similar. So this is a good time to pause the video and copy if you haven't already. See, I'm going to do a little mouse thing. Every once in a while the computer screen will close out on me. Okay, the second part, we have 2 examples on this page. I circled this little similar thing. We talked about it a long time ago when we first started geometry. You did a bell ringer that you had to do matching for shapes. But this little squiggly line here means similar. So I could say triangle ABC up here is similar to triangle XYZ. So for number 1, are the following rectangles similar? Well, they may be, they may not be. It just depends on what their scale factor is. So since it's a rectangle, I knew all of these angles are 90 degrees. So all the angles are congruent. So that's what I wrote here. All the angles are congruent. And then the longer side and then the shorter side. Now for this one, I labeled this triangle A and this rectangle A and this rectangle B. I could have named them 1 and 2 like I did before, but I'm just trying to show you can just label them any way you want as long as you always start with the same triangle. So in this, I'm so used to doing triangles with everybody. Okay, rectangle. So rectangle A, the long side is 36 on rectangle A, and the long side on this one is 45. And then the 2 shorter sides, I start with this rectangle, end with this one, so 18 on the top, 25 on the bottom. I reduced them. This one reduces to 4/5. Oh, there's Deku. I knew it was going to happen. So let me open this back up. Where is it? Okay, and I need to hit document camera. Where is it? There we go. It's back. I'm actually using my iPad to photograph or video the screen on my son's computer. So back to where I was at. So 36 over 5, if I divide both of them by 9, I get 4/5. But if I divide 18 by 9, I get 2. But if I divide 25 by 9, I am not going to get 4/5 at all. It's going to be like 2 point something. So they're not proportional, so they are not similar. Just because they're the same shape and one's bigger, they're both rectangles, it does not mean they're similar. So another time you can pause the video, color, copy, whatever you need to do. Okay, number 2. It says, are the following triangles similar? Well, I did the same thing I did for the very first example. I color-coded all 3 of my sides. I decided which side was similar. The 2 hypotenuses I did in purple again. My 90-degree angle to 30 degrees I did in green. So my 90-degree to 30 degrees I did in green this side. And this just helped me figure out that they are, what sides go with what, so I could set up my proportions. So again, I labeled 1A and 1B, and I did A over B is how I set up my proportions. So I ended up in, the orange side was 16 over 8, the green side was 30 over 15, and the purple side was 34 over 17. And if I divided all of those and simplified them, I got 2 for each of them. 16 divided by 8 is 2, 30 divided by 15 is 2, so is 34 divided by 17 is 2. So the triangles are similar. And something that isn't in the notes is I could say that K equals 2. That's the scale factor. One nice thing about the scale factor when we get to working with them, I hope we get to, is you can use the scale factor to find the other proportions or the other sides without having to use these big numbers. So if I knew this was 15 and I multiplied it by 2, I could get 30 for the other side, and 30 divided by 2 is 15. So you can go back and forth with that. So there are patterns that we can use. So there's the first page of the notes. I'm going to go ahead and probably make a second video for this, the back page. It won't be as long because this is already hitting almost 13 minutes. So this will be Exploring Similar Figures, page 1.